Two waves combine into one wave. Watch this. A sine wave and a cosine wave, added together, still trace out one single smooth wave, just shifted sideways and stretched taller or shorter. Here's the identity we're building towards. A times sine of theta plus b times cosine of theta can always be rewritten as r times sin of, open bracket, theta plus alpha, close bracket. Same shape, just repackaged into one wave. First we need r, expanding r sine of theta plus alpha using the compound angle formula and matching coefficients gives us r equals the square root of a squared plus b squared. Next we need alpha. Matching the other coefficient gives us tan alpha equals b divided by a. So alpha is just the angle whose tangent is b over a. Let's see where these formulas actually come from. Draw a right triangle with one leg of length a, the other leg of length b, and the hypotenuse is r. The angle alpha sits at the corner between side a and the hypotenuse. Now tilt that same triangle into a light three-dimensional view. Nothing about the maths changes, but you can see clearly r is just the diagonal distance stretched out from legs a and b using Pythagoras, exactly like the formula said. Let's use this on a real example. Take 3 sin of theta plus 4 cosine of theta, a equals 3 and b equals 4. First find r equals the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is the square root of 25, which equals 5. Now find alpha. Tan alpha equals 4 divided by 3, so alpha equals the inverse tangent of 4 divided by 3, which comes out to approximately 53.13 degrees. Putting it together, 3 sin of theta plus 4 cosine of theta rewrites exactly as 5 sin of, open bracket, theta plus 53.13 degrees, close bracket, one wave instead of two. Look at this rewritten form on the graph. Since sine only ever ranges between -1 and +1, the biggest this expression can ever be is r, which is 5, and the smallest it can ever be is -r, which is -5. No extra work needed, just read it straight off. Now let's solve an equation using this form. We want 5 sin of, open bracket, theta plus 53.13 degrees, close bracket, equals 3, for theta between 0 degrees and 360 degrees. Divide both sides by 5. Sine of, open bracket, theta plus 53.13 degrees, close bracket, equals 3 divided by 5, which is 0.6. Taking the inverse sine of 0.6 gives 36.87 degrees, but sine is also positive in the second quadrant, so the other solution is 180 degrees minus 36.87 degrees, which is 143.13 degrees. Subtracting 53.13 degrees from each of those to isolate theta. From 36.87 degrees, we get theta equals negative 16.26 degrees, and adding 360 degrees to bring it into range gives theta equals 343.74 degrees. From 143.13 degrees, we get theta equals 90 degrees exactly. So within our range, the two solutions are theta equals 90 degrees and theta equals 343.74 degrees. Notice how much easier that was than juggling two separate trig terms. Full process. Step 1. Identify a and b from the expression a sin theta plus b cos theta. Step 2. Calculate r as the square root of a squared plus b squared. Step 3. Calculate alpha from tan alpha equals b divided by a. Step 4. Rewrite as r sine of theta plus alpha. Step 5. Read off maximum as r and minimum as negative r, or solve equations directly in the simplified form. Watch out for this common mistake. Getting alpha from tan alpha equals b over a without checking the signs of a, and b can put you in the wrong quadrant. Always sanity check alpha against the original signs before moving on. Simplified version. A sin theta plus b cos theta becomes r sine of theta plus alpha. R equals the square root of a squared plus b squared. Alpha comes from tan alpha equals b divided by a. Maximum value is r, minimum value is negative r.